All right, Math 0099. Today we're just going to refresh ourselves with the special product rules for binomials. Where our blue card has that information on it. Product of binomials, we can use FOIL when the terms are not alike. Looking at the square of a sum, the first two terms have to be the same and the last two terms have to be the same. And we're squaring the binomial a plus b. The square of a difference, we have a minus b, the quantity times a minus b, or a minus b, the quantity squared for the square of a difference, where the first two terms are the same and the last two terms are the same, and we have the square of a difference. And we have the product of a sum and a difference, where we have a sum times a difference, but the first two terms are the same and the last two terms are the same. So trying to recognize, I see a binomial times a binomial, so I'm going to get out my blue card. Are the first two terms the same? Are the last two terms the same? And now, what operations do I have? I have a sum and a difference. So it's the product of a sum and a difference. And my answer is a squared minus b squared. So my answer in this case is x squared minus 25. We have the quantity p minus 1 squared. Well, that's a binomial times itself twice. So I'm going to get out my blue card, and I have a square of a difference, and my pattern is a squared minus 2ab plus b squared. In this case, a is p. I'm going to be collecting two like negative terms, and that'd be 1 times p. 2 times 1 times p would be 2p. And square your last term, and 1 squared is 1. P squared minus 2p plus 1. And remember that FOIL is used when I have a binomial times a binomial, but the first two terms are maybe alike. They are here, but the last two terms are different. So FOIL is our distributive process. FOIL, multiply the first terms, multiply the outer terms, multiply the inner terms, and multiply the last terms. And with FOIL, we know we look to collect like terms. And I have 7x plus 12. So here we have the product of a sum and a difference, the square of a difference, and here we have the square of a sum. It's a binomial times itself twice, so I know I have a binomial times a binomial. I have the square of a sum. The first two terms will be the same, the last two terms will be the same, and I'm adding. So my answer is a squared plus, I'll collect two like positive middle terms and square the last term. My first term is n, I'll square it, plus 2 times n times 3, 2 times the product of the two terms, and square your last term would be 3 squared, and then just tidying that up a little bit, n squared plus 6n plus, that's cubed, 3 squared, is 9. So recognizing your form patterns for the product of two binomials. Your blue card comes in very handy, so reference it as you wish. And then we're on page 4.7, or section 4.7, page 315. And we're looking at evaluating polynomials as they apply to our story problems. So the weight in kilograms of an elephant with girth of G centimeters at the heart, a length of L centimeters, and a footpad circumference of F centimeters can be established by the polynomial. So we can establish the weight of an elephant by substituting the measurements of that particular element into this polynomial. A field zoologist finds that the girth of a 3-year-old female elephant is 231 centimeters, the length is 135 centimeters, and the footpad circumference is 86 centimeters. Approximately how much does the elephant weigh? So the weight of the elephant can be approximated by 11.5 G plus, which is the girth, plus 7.55 times the length, plus 12.5 times F, the footpad circumference, minus 4016. And that is given to us. So now we send our representative out to the field, and they collect the data for our elephant. And our particular elephant's girth is 231 centimeters. The length is 135 centimeters. And the footpad is 86 centimeters. So careful substitution into this polynomial. We'll be able to solve for the weight. $11.5 times 236 is 2714 plus 7.55 times 135 is 1019.25 plus 12.5 times 86 is 1075, and subtract our 4016. So adding 2714 plus 1019.25 plus 1075, my positive values, copied that down wrong from my calculator, I guess, or typed something wrong on my calculator. 11.5 times 231, I may have typed 236, is 2656.5. So now adding all my positive numbers, 2656.5 plus 1019.25 plus 1075. For my positive numbers, 4,750.75, and I still need to subtract 4016. So the weight of our elephant with these particular measurements is 734.7, and we're measuring in kilograms. Careful substitution into a working polynomial. Okay, we're given a polynomial, and we're asked to identify the coefficient and the degree of each term, and then the degree of the polynomial. So we need to identify each term, its coefficient, the degree of the term, and the degree of the polynomial. Well, we've given a polynomial, 9x squared y cubed minus 14x y squared z cubed plus xy plus 4y plus 5x squared plus 7. So our first term from left to right is 9x squared y cubed. The coefficient is 9. The degree of the term is the sum of the exponents for this term. So 2 plus 3 is 5. Our next term, just be careful. We're subtracting here. This is the operation of subtraction, but our term is actually negative 14xy squared z cubed. Remember, change subtraction to addition and add the opposite so you know the sign of the term. So the coefficient is negative 14. The degree of this term is x to the first plus 2 would be 3 plus 3 is 6. Our next term is xy. The coefficient is 1 times xy, so 1. And the degree of the term, this is x to the first, y to the first. Adding the exponents, we get 2. Our next term is 4y with a coefficient of 4 and a degree of 1. The next term is 5x squared. The coefficient is 5. The degree of the term is the sum of the exponents, that'd be 2. And our last term is our constant 7, which is actually 7x to the 0 power. X to the 0 power is equal to 1 by definition. The coefficient is 7, and the term of the degree is 0 for our constant term. And then we can calculate our degree of this polynomial as the degree of the highest degree term. So the degree of the highest degree term is 6. So the degree of the polynomial is 6. Like terms have exactly the same variables with exactly the same exponents. So 3x squared y cubed and a negative 7x squared y cubed are like terms. And we're just moving a bit beyond what we've studied so far, where we have multiple variables within a particular term. So like terms, we want to check the variable x. Is it to the same degree? Yes. Variable y, is it to the same degree? Yes. So we have like terms. Like terms have exactly the same variables with exactly the same exponents. Then we're asked to add and subtract polynomials with multiple variables. We have a negative 5x cubed plus 3y minus 5y squared. We're going to add the polynomial 8x cubed plus 4x squared plus 7y squared. You might approach this by columnizing like terms. I'm just going to collect like terms. I have x cubed and an x cubed, so I have a negative 5x cubed plus a positive 8x cubed would be a positive 3x cubed. My next term is a y to the first degree. There are no other y to the first degree terms. I next have a y squared term. I'm going to change subtraction to addition and add the opposite, so I know I have a negative 5y squared. I'm looking for other y squared terms. So I have a negative 5y squared plus a positive 7y squared would be a positive 2y squared. And I have a 4x squared, but no other x squared terms, so plus 4x squared. Adding like terms. That seems most convenient for me. I'm collecting the like terms, I identify them, and then I add. You certainly can columnize first, and I think I show an example of that a bit later. Subtracting polynomials with multiple variables. 4x squared y plus x cubed y squared plus 3x squared y cubed plus 6y plus 10. And we're supposed to subtract 4x squared y. I'm columnizing now. So minus 6x cubed y squared. I'm columnizing my like terms. The next term I have is an x squared y squared. So I'm just going to scoot that in here. I have a minus 5y. And subtract 8 for a constant. I tried to columnize as I'm subtracting the polynomials. Notice I'm subtracting this entire polynomial. So that means I'm looking for the opposite of this polynomial, which will change the sign on each term. Be a negative, this can be positive, this will be negative, it's going to be positive, and this will be positive. We looked at that yesterday. The opposite of a polynomial, it's distributing -1 times every term in your polynomial, or just simply change subtraction to addition and add the opposite of each term. So now we've columnized 4x squared y plus a negative 4x squared y is 0. X cubed y squared plus 6x cubed y squared would be 7x cubed y squared. Looks like I have plus 3x squared y cubed and a negative x squared y squared, plus a 6y and a 5y would be 11y, and 10 plus 8 is 18. So perhaps columnizing for addition and or subtraction of polynomials will work for you. When we're subtracting, remember we're adding the opposite of this polynomial, which changes the sign of each term in your polynomial. Then 4.8 begins on page 324. Where we're going to be dividing polynomials. Ten x squared divided by 2x. We can break this apart as 10 times x squared over 10 over 2 times x squared over x. Kind of breaking down and getting our like terms together. It's all multiplication. And now 2 goes into 10 5 times, and x goes into x squared. Or remember your rules for exponents. Subtract the denominator's exponent from the numerator's exponent, and we'll have x left. X to the 9th over 3x squared. Well, again, we can break this apart. It's all multiplication. I have 1/3 times x to the 9th over x squared. So that's 1/3 times, subtract the denominator. When you have like bases in the numerator and the denominator, subtract the denominator's exponent from the numerator's exponent. We'll have x to the 7th. Negative 18x to the 10th divided by 3x cubed. And again, let's just break apart. It's all multiplication. Negative 18 over 3 times x to the 10th over x cubed. 3 goes into a negative 18, negative 6 times. And x cubed goes into x to the 10th. Like bases in the numerator and the denominator, subtract the denominator's exponent from the numerator's exponent. Get x to the 7th. Nine x to the 8th plus 12x to the 6th divided by 3x squared. So I have a binomial divided by a monomial. And I can break this apart as well. It's 9x to the 8th divided by 3x squared plus 12x to the 6th divided by 3x squared. I'm dividing each term in the first polynomial by the divisor. And now I can break these apart to find other names for one and or to simplify. So 3 goes into 9 3 times. I have x in the numerator and the denominator. Subtract the denominator's exponent from the numerator's exponent. X to the 6th. 3 goes into 12 4 times. I have like bases in the numerator and the denominator, so we subtract the denominator's exponent from the numerator's exponent and get 4. X squared plus 5x plus 6 divided by x plus 2. Now I have a trinomial divided by a binomial. Longhand, it looks like this. So x goes into x squared. X times what would give you x squared? X. X times x is x squared. So x times x is x squared. And 2 times x would be a positive 2x. And then in long division, draw your line and subtract. Notice what I'm doing. Subtract the entire polynomial. So I'm subtracting a polynomial, which means I have the opposite, change the sign of each term. So this will be a negative x squared for 0, and this will be a negative 2x plus 5x will be 3x. And bring down your next term. Well, x times what will give me 3x? Positive 3. 3 times x is 3x plus 3 times 2 is 6. Draw your line and subtract the entire polynomial. That's the most common mistake. Subtract the entire polynomial, and we are looking for the opposite of each term. So I have a 3x plus a negative 3x will be 0, and this will be negative x6 plus positive 6 is 0 for a remainder of 0. So let's check this. When I'm checking division, I take my divisor times my quotient, and it should be equal to the dividend. Well, with FOIL, I have x squared plus 3x, inner terms plus 2x. My last terms will be plus 6. FOIL, we look to collect like terms, x squared plus 5x plus 6, x squared plus 5x plus 6. So you can circle your answer. We have x squared plus 2x minus 12 divided by x minus 3. Well, that's a trinomial divided by a binomial, and long division, x minus 3 goes into x squared plus 2x minus 12. Well, x goes into x squared how many times? X times x will be x squared. And x times a negative 3 will be a negative 3x. Draw your line and subtract the entire polynomial. So these are going to be opposite signs now. That goes to 0. This is going to be positive, so I'll get positive 5x. And bring down your next term. Now x goes into 5x how many times? 5 times x would be 5x. 5 times a negative 3 would be a negative 15. Draw your line and subtract the entire polynomial, which changes the sign of each term. So this was negative, that goes to 0. This is negative, it's going to be positive. Positive 15 plus a negative 12 be a positive 3. So I have a remainder of 3. Now let's check this. My divisor, x minus 3, times my quotient, plus a little bit more, I had a remainder. So multiplying FOIL, x squared. The last will be plus a 5x. My inner terms are a minus 3x. And my last terms will be a negative 15. But I have this plus 3. Collect like terms if you can. X squared plus 2x. A negative 15 plus 3 would be a negative 12. X squared plus 2x minus 12. My divisor times the quotient plus any remainder is equal to the dividend. So you can circle your answer. Then your caution when we're dividing polynomials, x cubed plus 1 divided by x plus 1. Remember longhand, this is x plus 1 goes into x cubed, but we have to think about those missing terms. We have to include all the placeholders. So we'll have plus 0 times x squared plus 0 times x to the first degree, but I do have a constant, plus 1. So don't forget your missing terms. You have to show all your placeholders. So x goes into x cubed. I guess x squared times. X squared times x would be x cubed. And x squared times 1 would be 1 x squared. Draw your line and subtract the entire polynomial, which changes the sign of each of these terms. So I end up with a negative x squared. X times what would give me a negative x squared? Negative x. Negative x times x would be a negative x. Oh, and bring down your next term. And a negative x times 1 would be a negative x. Draw your line. And subtract this entire polynomial, which changes the sign of each term. So this is a positive, goes to 0. This is positive. So I end up with positive x. Bring down your next term. X goes into x how many times? 1. 1 times x is x. 1 times 1 is 1. Draw your line and subtract the entire polynomial, which changes the sign of each of these terms. X plus a negative x is 0. 1 plus a negative 1 is 0 with a 0 remainder. So our answer is x squared minus x plus 1. And how would we check? Your divisor times your quotient and use distribution. Okay, that takes us through the chapter, and we begin looking at the chapter summary and review together on page 331. And I usually go through these chapter summary and reviews with you. Notice that they're kind of, there's a center line there. we have the first column where a very similar problem is worked out for you, and then we're challenged with our practice exercise. So I'm supposed to multiply z to the 5th times z cubed. All our exponent rules, like bases, in multiplication, we add exponents. Next on page 332, I'm supposed to divide and simplify a to the 4th times b to the 7th divided by a squared b. A to the 4th, b to the 7th divided by a squared b. I can break this apart. A to the 4th over a squared times b to the 7th over b. Like bases in the numerator and the denominator, keep the base and subtract the denominator's exponent from the numerator's exponent. Like bases in the numerator and the denominator, subtract the denominator's exponent from the numerator's exponent. We're supposed to simplify. The quantity x to the negative 4th times y squared divided by 3z cubed, close, all raised to the 3rd power. X to the negative 4th times y squared divided by 3z cubed. The quantity is raised to the 3rd power. Well, our rules for exponents, when I have a base raised to the power, the quantity raised to the power, we multiply exponents. So I have x, the negative 4 times 3 would be a negative 12. Y squared, 2 times 3 is 6. 3 to the 1st degree, that'd be 1 times 3, 3. And z cubed times 3 would be 9. And now I just want to clean this up a little bit. X to the negative 12, y to the 6th over 3 cubed is 27, z to the 9th. And then at MyMathLab, double check always before you say this is your final answer. Make sure you're showing your answer in the form that they're looking for. And they most likely will say, show your answer using only positive exponents. So we're going to take x to the negative 12 to the denominator and change the sign of the exponent. That leaves y to the 6th in the numerator. I have 27z to the 9th. So it's y to the 6th. We usually put our constant out in front. 27x to the 12th, z to the 9th. Your next example is to collect like terms, and we did that today. Arrange in columns or carefully collect your like terms. It's best that we always change subtraction to addition and add the opposite so you know the sign of the term itself when you're collecting terms. We're supposed to multiply x to the 4th minus 3x squared plus 2 times x squared minus 3. So I have a trinomial times a binomial. Now we can rewrite this. Remember, something times something. 3 times 4 is the same as 4 times 3, the commutative law for multiplication. So I'm going to do this. So I'm distributing 2 terms across the trinomial instead of 3 terms across the binomial. And now I'm going to do something a little bit different also. Change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite. And I want to distribute each term in the first polynomial times each term in the second. So let's just do the distribution part. I'm going to distribute a -3 times each term in the second polynomial. So now I have the first term of the first polynomial times every term in the second polynomial, plus the second term in the first polynomial times every term in the second polynomial. Go ahead and distribute to expand, and then collect like terms. Then we're asked to multiply y plus 4 times 2y plus 3. Oh, that's a binomial times a binomial. So I know I have some special product rules for that. Are the first 2 terms the same? No. So I will have to use FOIL to solve. X plus 5 times the quantity x minus 5. Oh, that's a binomial times a binomial, so I'm going to get out my blue card. Are the first 2 terms the same? Yes. Are the last 2 terms the same? Yes. I have the product of a sum and a difference, so my answer is a squared minus b squared. So I have x squared minus 25. Next, multiply the quantity 3w plus 4, the quantity squared. 3w plus 4, the quantity squared. Well, that's a binomial times a binomial. I have 3w plus 4 times 3w plus 4, so I'm going to get out my blue card, and that looks like it's the square of a sum. So my answer is a squared. I'm going to be collecting 2 like positive middle terms, and I square the last term. A in this case is 3w. So 3w, the quantity squared, plus 2a, in this case, a's position would be 3w. B's position is 4. And then square b, 4 squared. 3w squared, 3w times 3w would be 9w squared, plus 2 times 3 is 6 times 4 is 24w, plus 4 times 4 is 16. So again, rehearse and practice your special cases for the product of 2 binomials. Chapter summary and review, selecting certain problems that try to emphasize or point out key topics within the chapter. Number 13, we're supposed to subtract. A cubed b squared minus 5a squared b plus 2ab. And we're going to subtract the polynomial 3a cubed b squared minus ab squared plus 4ab. Remember, when we subtract, we change subtraction to addition and add the opposite. And so we're now asking for the opposite of this polynomial. And the opposite of this polynomial will change the sign on each term. So we're going to be adding our first polynomial plus the opposite of the second polynomial. And That's kind of the key trick when you're subtracting. You'll be subtracting the opposite of the polynomial. And then our division today, we're given a polynomial. We're supposed to divide by a binomial. Longhand division, x squared minus 4x plus 3. Just make sure with division of polynomials that you check and complete all missing terms. They're placeholders. And I have x squared, x to the first degree, and x to the 0. So I'm good there. And then you want to make sure you know the sign of that term. So x times what will give you x squared? X times x is x squared. 5 times x is 5x. Draw your line, subtract the entire polynomial, which is the opposite of this polynomial. Opposites be 0. This is positive, but I'm looking for its opposite, so I'll end up with a negative 9x and bring down the next term. X times what would give me a negative 9x? Negative 9. Negative 9 times x is a negative 9x, and a negative 9 times 5 is negative 45. Draw your line and subtract the entire polynomial. So this is going to go to positive for 0. This is going to go to positive for 48. So I have a remainder of 48. Checking my divisor times my quotient plus a little bit. I'm going to use FOIL. X squared minus 9x plus 5x minus 9 times 5 is 45 plus 48. X squared, collect like middle terms. Looks like that's going to be a negative 4x. And a negative 45 plus positive 48 would be a positive 3. X squared minus 4x plus 3 is your dividend. So you can circle your answer. All right, tomorrow we'll go over sample questions from the test for chapter 4. And probably continue with chapter 5. Thank you very much.